Okay guys, so this is going to be a review for your upcoming test on Monday for those of you who need to take it. Again, if you have a 90 or greater in the grade book, you don't have to take this test because that means that you've done very well on all of the other homeworks and the quiz. So you've pretty much demonstrated that you know your stuff. But for the rest of you, if you're below a 90, then you need to take this so I can assess your knowledge. And I apologize, my dog is gnawing on a bone right behind me, so you're going to hear noise. And I have to keep her busy while I'm making videos, otherwise chaos takes place. So what I'm going to do is I'm going to do a few examples and just remind you of a few things. I mean, all you have to do is look at the other videos. I've taught it. And for some of you, I've made one or more solution videos and sent them. So you have more than enough information than you need in order to be successful on the test. So I'm not going to, drag this out. But essentially, so I'm in the ebook right now. And whether you want to use the ebook or the real book, it doesn't matter. The pages correspond, but what we're going to do is 10.2, 10.3, and 10.4. And if you scroll all the way down or go to the back of the chapter 10 in your book, you see there's a chapter summary, which is always a good thing to review. And there are review exercises, so let's click on this. Let's see what these start at. Okay. Yeah, okay, so we'll start here. So for the parabola, right? So remember, you're going to have your little, let me focus this. It's in very close. There we go. You're going to have your, in fact, let me just change this a little bit more. You're going to see some wires because I've got my professional microphone out this morning and I just didn't have time to deal with the wires. But you're going to have your formula sheet. And you started with parabolas. That's how your test is going to start, with parabolas. So, well, not necessarily, because actually the test randomizes the questions, so you rarely get to the same question. But anyway, these are the three things that are going to be in there. Remember, with the ellipses, you had a little formula for eccentricity. And I gave you all the points for those in EDSB. I told you to ignore those. I mean, the formula's easy enough. Many of you found it. But you're not going to have to worry about eccentricity. Now, if a question happens to tack on an eccentricity, then you can just ignore that in the quiz because it wouldn't be counted in for the points. All right? And then don't forget that there's a difference between your so-called Pythagorean theorem for the ellipse and the one for the hyperbola. And then finally the classifying, right? So this is the general form down here, and based on some characteristics you can tell whether you've got a circle, a parabola, ellipse, or hyperbola. Okay, so let's just start with the parabola, and I'll do some of the evens here. And what you can do for practice is you can do the odds, right? Because you can check the back of your book for the answer. And if you are not getting something right, then you can send me a message and I will help you. So in number 14, what we're asked to do up here, so let's go back to what it's saying. We want to find the standard equation of a parabola. Right, given the characteristics and sketch it. So essentially with parabolas, that's what you're going to do. You're going to have to find the standard equation and you're going to have to identify a sketch of the correct parabola. So in this one here, they're giving us the vertex of 4, 0 and a focus at 0, 0. And what you should always do first and foremost is make a sketch, right? So I've got a focus here, that's a focus at 0, 0. And at 1, 2, 3, 4, 0, I've got the vertex. And what I know is that the parabola opens toward the focus, right? The focus is inside the bowl or inside the parabola. So I know my parabola is going to open to the left. And I need to find the standard equation. Well, the other thing I know is that the distance from the vertex to the focus is called p, so that's 4 units. However, be very careful here, because while it's 4 units distance-wise, first and foremost, I've got a horizontal axis, right? And right down here, this is what I was trying to get with some of you who kept finding this simpler formula, and you can use a simpler formula depending on where your parabola is centered or where the vertex is centered at. But you know, if the parabola opens to the right, then P has to be a positive number, and if it opens to the left, P has to be negative. So while this distance is truly a positive 4, what I can determine from this is that this opens to the left, so P is negative 4. Why do I need that? Because my formula goes like this, right? And generally speaking, you have to find the P. Okay, so H and K are the coordinates of the vertex for a parabola. So I'm going to go ahead and plug those in. Use black. So we have y minus 0 squared is equal to 4. Now I know P is negative 4, so I'm just going to pop that in. X minus 4, right? Y minus 0 is y squared is equal to negative 16 times x minus 4. This would be the standard equation of the parabola given the vertex and focus that it gave us. I'm not going to put any problems in involving the directrix. You know, just a quick reminder that the directrix is a line perpendicular to the axis of symmetry, right, which is P units away from the vertex. So I'm not going to give you any problems on the test that involve the directrix. It's not part of your curriculum, so you don't need to worry about it. But this is essentially what you have to do. This is it, okay? In 10.3, we're going to find the standard equation of the ellipse. So for example, I'll do number 22, and they're giving us vertices of 0, 3 and 10.3, and a minor axis has a length of 4. Now remember, the ellipse is probably the most involved of the 3 conics, because you know, you have to pay attention to something. You have to remember, for instance, that the major axis contains the vertices and the minor axis contains the co-vertices. And we have to determine which axis we're dealing with. So again, make a quick sketch. And I'm going to do these in increments of 2. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. All right, so there's my little axis, and I'm going to plot my vertices. I've got one at 0, 3, so 3 is here, right? These are 2, 4, 6, 8, so 3 is in between 2 and 4. And the other one is at 10, 3. So what I know, these are my vertices, right? My ellipse is going to go something like this. So I've got a horizontal major axis. And what that means is that my formula is going to be x minus h quantity squared over a squared plus y minus k squared over b squared equals 1. I know what my vertices are. I know the length of my minor axis. By the way, I need the center, right, in order to plug in for h and k. Now the center is halfway between the 2 vertices on the major axis. And it's also halfway between the 2 co-vertices on the minor axis. But since we have the major axis done, that's what we should use. And if you look in your formula sheet, there is an equation for the major axis. It says that the length of the major axis is equal to 2 times a. Well, the length of this thing is 10, right? So 10 is equal to 2a, so we can find our a. 10 divided by 2, which is 5, is equal to a. So I know what my a is. It's 5. Now, that doesn't help me with my center, but if this is 10 units long, and my center has to be in the middle, then it makes sense that my center would be at what, right? Well, this is a height of 3. So I know the y-coordinate has to be on 3. The x-coordinate has to be 5. So the center is at 5, 3. So if I go over 5 and up 3, there's my center. Okay. Now I know my minor axis goes through that center, and the formula for the minor axis is 2 times b. So if the length of the minor axis is 4, and that's equal to 2 times b, then what I know is b is equal to 2. So I can go 2 units here, and 1, 2, so 2 units here. This is my minor axis, and my ellipse is going to look something like that. Now, I may have to find c, but not for this equation, right? So let's put the equation together. So let me move this over. So we're going to have x minus 5 squared over a squared, so a was 5, plus y minus 3 squared over b is 2 equals 1. And cleaning it up for WebAssign purposes, you would have this. Okay? So we found the standard equation of the ellipse, given the vertices and the minor axis. You know, they may give you the major axis in the vertices, or foci, or something like that. So there are many different variations to this, but again, you've got the formula sheet, and based on that, that can help you a lot. Now, the other thing you might see with the ellipse, I can't move this over. Let's see, can I move this page over? No. Oh, I didn't want to do that. I thought I was moving it over. Well, that's the chapter test. That's another thing you might want to do, review exercises, is look at that chapter test and try the odds on that. But the other thing you're going to have to do, according to this, is, you know, in curve sketching, you might have to find the center, the vertices, the foci, again, not the eccentricity, given the standard equation. So let's look at a problem like that. So let's do number 28, let's say. So in 28, we've given the standard equation, which is x minus 4 squared over, I'm going to write this as 5 squared, plus y plus 3 squared over 7 squared equals 1. The first thing they want us to find is the center. Well, we know that the center is h comma k, which is 4 comma negative 3. So the center is done. All right. And again, you can refer to this, right? Now here's the other thing. Here's my formula sheet for ellipses, right? And the bigger number here is under y. So if the bigger number is under y, then that means what? It means I'm going to have a horizontal or a vertical axis, right? That's really important because I need to know what formula I'm dealing with here. Well, if you're still not sure, hold that thought, okay? Because so far we can plot the center. Let's remember some things about this. We need to find our A and our B. Now, according to the formula sheet, this is A and this is B. Why? A is always, in an ellipse, A is always the bigger number, right? So again, if you come back here, you notice how the A and the B swap. The bigger number is always A. What is A? Is the distance from the center to a vertex in an ellipse, right? So it's always the bigger number. B is always smaller because it represents the co-vertices, or the distance from the center to a go-vertex on the minor axis. So the B is shorter. The A is the longer part, or the bigger number. And if the bigger number is under y, we're going to have a vertical major axis. And if the bigger number is under x, we're going to have a horizontal major axis. Well, here if you look, the bigger number is under y, so we're going to have a vertical major axis. So I know that my A is 7, my B is 5, and we might as well go ahead and find C. Remember, for this formula, it's a squared equals b squared plus c squared. So what that means is that c squared is equal to a squared minus b squared. And if I plug those in, I'm going to have 49 minus 25, which is 24. And if I take the square root of that, I'm going to have to simplify it. Remember, this is 6 times 4. The square root of 4 is 2 root 6. So this would be the simplified version of C. Let me move my mouse. All right, so we found the center. We wanted us to find the center, the vertices, the foci. So let's find the vertices. The vertice formula, so again, we had the bigger number under y. This is a horizontal, the bigger number under y, so it's a vertical major axis. And according to the formula for vertices, that's going to be h plus or minus a comma k. Well, we know what our h is. It's 4 plus or minus a. What is a? A is 7. Comma k, well, what is k? It's negative 3. So if I clean this up, I'm going to have 4 plus 7 comma negative 3 and 4 minus 7 comma negative 3. And let's see what this is going to be. This will be, wait a minute here. Oh, I did the wrong one. I'm sorry. I was looking at the wrong thing. That's the problem with the formula sheet. Okay, vertices. So the vertices, I'm sorry, vertical axis, is going to be h comma k plus or minus a. My bad. So h is 4, comma, k is negative 3 plus or minus 7. So it's going to give me 4 comma negative 3 minus 7 and 4 comma negative 3 plus 7. If I clean those up, I'm going to have 4 negative 10 and I'm going to have 4 4. So my vertices will be at 4 negative 10 and 4 4. I don't know why, but I want this. I'm thinking that this is a horizontal axis for some reason. So I found my vertices. Over here, I'm going to find my foci. The formula for the foci on the major axis is h comma k plus or minus c. So that's going to be 4 comma negative 3 plus or minus 2 root 6. Now I understand that's an ugly number, but for WebAssign you would type it in as 4 comma negative 3 plus 2 root 6 and 4 comma negative 3 minus 2 root 6. To graph it, piece of cake, right? Oh, these wires are driving me wild. So let me bring my center back down here. My center is 4 negative 3. That's my center. A is 7, B is 5, and C is 2 root 6, although we don't need this anymore. But back to our formula, we're going to have x minus 4. Sorry, we don't need to do that. We just need to graph it. So the center is at 4, 2, 4, 2, 4, 6, 2, 4, 6, 8, 2, 4, 6, 8. So I'm doing in twos again. It's 4, negative 3. So here is the center of my ellipse. And from that center, I know I've got a vertex at 4, negative 10. 4, 6, 8, 10. So at 4, negative 10, I've got a vertex there. And at 4, 4, right? So 4, 2, 4. I've got a vertex there. So this is my major axis. And the foci, I would have to use my calculator to get an idea, but you know, your ellipse is going to go something like this now. And the foci have to be in between the center and the vertex. So if I use my calculator and do, so I know it's going to be at 4. If I do negative 3 plus 2 root 6. So negative 3 plus 2 root 6. So just to give you an idea here, it's going to be about almost 2, right? So if I go over 4 and almost 2, I'm going to have a foci there. And if I go over 4 and then now from here to here, it's going to be much different, right? It's going to be negative 3 minus 2 root 6. So if I copy paste that in there and change the sign, like so, then I'm going to get negative, almost negative 8. So I come over to 4 and I go down almost negative 8, and my other focus is right there. Okay? Now, these I'm saving for last because that's what we did last in the last section. Let's scroll on through here again, and finally we've got the hyperbola, right? So definitely you're going to want to do something like number 32. You're given the vertices. So let me write those down. You have the vertices of 5, 2, negative 5, 2. And you've got foci at 6, 2, negative 6, 2. And you're asked to find the standard form, oops, of the equation. There we go. Okay, find the standard form of the equation given that information. So we know this is a hyperbola, right? We need to know what our transverse axis is. Is it major? Is it minor? Okay, again, we've got our formula sheet to help us. But we want to find the center of this thing, right? We want to find the equations of the asymptotes because remember, we need to, you may be asked just to find the equation of the asymptote, so we want to use that. So anyway, here, if I make a quick sketch, I can orient myself. So let's do that. So we're going to go 2, 4, 6, 8. So again, I'm going in 2s. Okay. And if I plot my vertices, I've got a vertex at 5, 2. And I've got another one at negative 5, 2, 4, negative 5, positive 2. So bingo, I know I've got a horizontal major axis. Wait a minute, this is a hyperbola. Dang it. I don't know anything. Those are my vertices, sorry. But that's okay, because that's the distance between the vertices. That means that the center has to be right in between those, right? Well, guess what? If this is 5 and this is 5, this is a length of 10, and 10 halves is 2. So right here at the point 0, 2 is my center. So my center is the point 0, 2. Now, because of this, I know that if these are my vertices, I know that my hyperbolae, my hyperbolas, are going to have to open like this. Right? My center is the midpoint between the vertices. I know the foci. One is at 2, 4, 6, 2. Here's the focus. And 2, 4, 6, 2. And here's the other focus. Okay? I may have to find the equations of the asymptotes, but in this case here, what they really want is the standard form. So since I have a horizontal transverse axis, I know my formula is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay? I've got my center, I've got my vertices, I've got my foci. I just need to plug stuff in. Ooh, I have to find an a and a b, right? Well, again, remember for the hyperbola, this is classical Pythagorean theorem. A squared plus b squared equals c squared, right? So it's an easier one to remember, but again, you're going to have the formula sheets during the test. So let's see here. Let's see what we can figure out. If our center's at 0, 2, and our foci are at the values that are given, then what I know is my A and my C. And again, I'm going to go back. Let's see if I can go back 10. Because this is a really important picture. And I can't stress this enough. So let's see, where is it? Oh, I'm going to go this way. Is it this one? No. Where is the picture I'm looking for? And why can't, oh, here we go. Maybe it is over here. For some reason it wouldn't let me scroll a second ago. It's here. This picture. This is the picture. This is super important because it orients you as to the A, the B's, and the C's, right? So look, the distance from the center to a vertex is always A, and the distance from a center to the focus is always C, okay? So that's going to help you determine your A and your C. Well, if you look back at this picture, the distance from the center to the vertex is 5, right? So this is my A. So I know that A is 5. And what is B? Oh, I don't know, but I know what C is. C is 6, right? I can find B by using this little formula. So what I have is 36 is equal to 25 plus B squared. If I subtract 25 from B squared, I get that. That's a 9, I think, right? 9 is equal to B squared. This looks like B is, no, 25 minus 36 is 11. So B is equal to root 11. Okay, so let's plug this into our formula. Again, our center was 0, 2. So it's x minus 0 squared over a squared minus y minus k squared over b squared. So root 11 squared is just 11 equals 1. And that's the standard equation given some of the other information such as the vertex and the foci. I need to go back to the review exercises. What if, so this is not part of the question, but what if, because I'm sure you will have one of these on the test. Where was I? What number was this again? 20 or 30 something, 30, here, 32. Okay, what if I asked you for the equation of the asymptotes? Well, you know, you have a horizontal transverse axis, okay? The equation of the asymptote for the horizontal is y equals k plus or minus b over a times x minus h. I mean, you've got the formula. You know what your a and your b and your h and your k in. It's just a matter of plugging it in and cleaning it up. So remember that the center was 0, 2. This was the center. So we're going to have y is equal to 2 plus or minus. B was root 11. A is 5 times x minus 0. And cleaning this up, we'd have 2 plus or minus root 11 fifths times x. And that would be it. Okay, those would be the equations of your asymptotes. Good girl, Ella. Hi, Ella. I'm almost done, Ella. I'm almost done. Another situation you might come into is to sketch. So let's do 36 real quick. You know, you're given the standard form and you're asked to sketch the hyperbola. Okay, it says find the center, vertices, foci, and the equations of the asymptote. So this is a perfect question. We've got y minus 3 squared over 9 minus x squared is equal to 1. And if this bothers you, put a 1 under there. All right? This is the standard equation. The bigger number is under y, right? So again, as a reminder, if y comes first, then you're going to have a vertical transverse axis. So that's what we expect to have here, right? So what I'm going to have, I'm going to rewrite this as y minus 3 squared, y minus 3 quantity squared over 3 squared minus x squared over 1 equals 1. And what I know is that a is equal to 3 and b is equal to 1. Calm down. Okay, now I have to find the center. Well, the center's easy. It's hk, right? And h is 3. Now k is 0. Done. So my center is 3, 0. No, my... Wait a minute here. Sorry. It's too early in the morning. 0, 3. I'm sorry. 0, 3. Okay, so it's 0, 3. Right? I know my A is 3, my B is 1, that's already established. To find the C, again, I've got C squared is equal to A squared plus B squared, which is root 10. So my C is root 10. Why do I need that? Because I need to find the foci. And that's part of it, right? The foci. I need the C for the foci. Okay, so the center is done. It's at 0. I'm going to rewrite this. It's at 0, 3. This is the center. Okay. The vertices, well, again, this is going to be a vertical axis. So the vertices are going to be at h, comma, k plus or minus a, right? So h was 3. Oh, sorry, h is 0. I want to keep doing that. I don't know why. And then k is 3 plus or minus a is 3. So our vertices are going to be at the point 0, 3 plus 3, which is 6, and 0, 3 minus 3, which is 0. The foci are going to be at h, comma, k plus or minus c. So we've got our h, which is 0, our k, which is 3, plus or minus root 10. So the foci will be at 0, comma, 3 plus root 10, and 0, comma, 3 minus root 10. Again, weird little numbers, but no big deal. And if we had to sketch this, then what we're going to look for, or what a grader or what WebAssign is going to look for, is that your vertices are in the correct places, your foci are in about the correct places, your center is correct, your major axis is definitely vertical versus horizontal, those kind of things. But if we had to sketch this, so 2, 4, 6, 8, 10. I don't need to go out this far on this one, but you never know. Anyway, my center was at 0, 3. So there it is. I have a vertex at 0, 6. So 2, 4, 6. And another vertex at 0, 0. So this is a very tiny major axis, right? Because of the way I scaled my coordinate plane. I know that my foci, I know that my ellipse is going to go something like this, and I know my foci have to be somewhere in between, right? 3 plus root 10 is a little more than 3, so something like that, and a little less than that. But you're going to get to choose, right, from a multiple choice on the WebAssign when it comes to graphs anyway, so that's going to be the easier part for you. Finally, what you need to know is how to complete the square so that way you can determine what your conic section is. Is it a circle, an ellipse, a hyperbola, so forth, okay? So you're going to be given the general equation, and you're going to have to complete the square so that way you can figure that out. So let's do one, and then I will stop. Again, you can watch this video, and I would highly suggest you rewatch the other videos and do the odd practice either in the review here, go to the chapter test, which comes up I think next, or anyway after the review in the book, and you should be fine. So I don't know, let's do 38. 38, we have negative 4x squared plus 25y squared minus 8x plus 150y plus 121 equals 0. And what I'm going to tell you right now is, remember, these formulae are at the bottom, so this is the general form, okay? And the easiest one to spot is the circle, because the coefficient of x squared will equal the coefficient of y squared. A is equal to c. Well, guess what? They're not equal, so I know that's not a circle, okay? It's not. And in fact, if I multiply a times c, So negative 4 times 25 is negative 100, and if it's less than 0, I know it's a hyperbola. So guess what? I don't have to go through all the work if I just have to describe what it is. All I have to use are these formulae. Now if I'm asked to write the standard form, then I got to do the work, okay? So it's actually just asking you to sketch it. So in other words, in order to sketch it, you'd have to write it in standard form. So let's write this in standard form. Remember, we're going to put our x's and y's together. And you can put the box now, right? And I'm going to bring that 121 over to the other side. Okay, now over here I'm going to factor out a negative 4. And we're left with x squared minus, plus 2x, be careful with that sign, plus the box squared. Here I'm going to pull out a 25. We're going to have y squared plus 6y plus the box squared is equal to, now remember, since I factored stuff out on the left, I'm going to do minus 4 times box plus 25 times the box, right? On the right. Now let's complete the square. Half of 2 is 1. 1 squared is 1, so I'm putting the 1 there in my trinomial, and I'm putting a 1 here. In this one here containing y's, half of 6 is 3. 3 goes in the box here, and 3 squared is 9, so I'm going to put the 9 over there. So now I can rewrite this as negative 4 times x plus 1 squared plus 25 times y plus 3 squared is equal to, where's my calculator? So we got negative 121 and negative 4 is negative 125 plus 25 times 9. Ooh, that was not supposed to be squared. Is a positive 100. Nice. But we have to have a 1 on the right, right? So that means we're going to divide every term both sides by 100 to make that happen. And 4 goes into 100. So negative 4 goes into itself once, it goes into 100 25 times. 25 goes into itself once, it goes into 100 4 times. So what I'm left with is negative x plus 1 squared over 25 plus y plus 3 squared over 4 is equal to 1. Now the problem is, this is supposed to be a hyperbola. The signs are definitely different. We can't keep it like that, so we're just going to rearrange these. So we would write this as y plus 3 squared over 4 minus x plus 1 squared over 25 is equal to 1. All right? And not only that, now I know my center is negative 3, negative 1, right? Y comes first, so I'm going to have a vertical axis, which doesn't seem right because did I make a mistake here? 25 goes in 100 4 times, 4 goes in 25 times. No, that's right. Well, let's see. My center, gosh, I keep doing this. I'm having dyscalculia today. My center, I'm sorry, is negative 1, negative 3. A is 2, and that means that B is 5, and C squared is going to be 4 plus 25, which is root 29. Right? So if I had to sketch this thing, I might want to find the asymptotes, but we're not going to do that. I know I can plot my center at negative 1, negative 3. There's my center, right? And I know that I'm going to have, you know what I keep doing? I keep screwing up my hyperbola with my ellipse. That's what I'm doing this morning. And it's 7:17. And besides that, I already made this video once last night and it came out like the chipmunk, so I had to make it again this morning. I don't know why it came out like the chipmunks, but I can't seem to fix it. So this is take 2. And so, you know, I remember what I did. But anyway, yeah, I'm confusing my hyperbolas with my ellipses. All right, so don't do as I do there. But anyway, the vertices, right? If I need to, so I have my center, but I need to find my vertices here. And since this is a hyperbola and y comes first, then what I know is that my vertices are going to be h, comma k, plus or minus a. And h is -1, comma, k is -3, plus or minus 2. So my vertices are going to be at -1, -3 plus 2 is -1, and -1, -3 minus 2 is -5. So I'm going to have vertices at -1, -1, and -1, -5. So if this is my center, right, this is -1, here's -1, and this is -3. Okay, so anyway, if I go over -1, -1, I'm going to have a vertex there. And if I go over -1, -5, I'm going to have another vertex here. Right, so there's my major axis there, or my transverse axis, I should say. If this is a vertex here, then I know this is going to open up and down like that, right? So I really don't need to do it all algebraically, because again, you guys are going to have multiple choice on your test. But if you're asked to find, if you're asked to find the vertices or the foci or the equations of the asymptotes, or to sketch it, or to take the general form and write the standard form so that you can sketch it or give some other information, you know what to do. All right, so go back over the other videos if you need to, do the odds, check with Bob, see if you know, you end up with the right answers, and let me know if you have any questions. All right, I'll be looking intermittently over the weekend for any questions that may arise. It'd be best if you could have most of your questions ready by tomorrow, because during the week I'm on pretty much the whole time online, so I can respond very quickly. But on the weekends I have my own things that I need to do with my own family, so I have a tendency to stay away from Edsby and the computer, considering I'm on this thing 10 to 12 hours each and every day during the week. All right, so anyway, talk to you soon. Hope this helps.